Welcome to Inventek Systems Embedded Talk Series. Today we'll be discussing the ES-Wi-Fi module. So pull up a chair and join us. The ES-Wi-Fi module is based on Inventek Systems' own ISMA 4319 SIP, which itself is based on Broadcom's BCM 4319 802.11 BGNN chip, and includes an STM ARM 32-bit microcontroller. The ES-Wi-Fi module also comes in two versions depending on antenna needs. Key features of the ES-Wi-Fi module include a custom AT command setup for easy communication and setup for networks, OS independent, no drivers required, simplifies embedded communications, no TCP stack required, minimum software development, works with any class of microprocessor, 8-bit, 16-bit, or 32-bit, can be used to find and scan for Wi-Fi networks, and can join networks found, can ping systems located on a network, integrates a Wi-Fi access point with DHCP configuration, has configurable protocols and ports for TCP UDP communication, supports GPIO and ADC inputs. Networking features include ICM for ping, ARP, and DHCP. New features in development, power savings including 802.11 power save, WPS, and IPv6. As mentioned earlier, the ES-Wi-Fi module has multiple options for antenna. It is available with a etch microstrip antenna, a UFL connector, or a ceramic microchip antenna. Key benefits of the ES-Wi-Fi module include Wi-Fi 802.11 BGNN wireless networking modes, world's smallest Broadcom embedded Wi-Fi module, plug-and-play, smallest footprint integrated antenna, fully FCC certified, full software and hardware customer support, expands Broadcom's Wi-Fi customer base to allow support for all embedded designs. As mentioned earlier, the ES-Wi-Fi module has an AT command set, which makes embedding Wi-Fi as easy as 1, 2, 3. There is no TCP stack requirement, there is no operating system requirement, there is limited Wi-Fi knowledge required, and fast time to market using the AT command set of the ES-Wi-Fi module. The ES-Wi-Fi module is available on an evaluation board and comes in two versions. One version of the evaluation board has a UFL antenna and a chip antenna. The other has a ETS PCB antenna. In addition, there are virtual USB serial ports that can be used to talk to a host computer, SPI via an expansion header, which allows interfacing switches, LEDs, temperature sensors, and external SPI flash. The evaluation board allows for external power, and JTAG is supported through one of the USB ports. Now it is time to dive into the ES-Wi-Fi module's AT command set and to see how to use the AT command set for embedded Wi-Fi applications. For the demos that follow of the AT command set, we'll be using a program called Terratorm for terminal console, and we'll be using a program called Socket Test for doing TCP communications over a network. Both programs can be found on the internet. The terminal console program has been set up to support 115/200 baud, 8 bits, 1 stop bit, and non-parity. When you apply power to the ES-Wi-Fi module, the first thing you will notice is an ES-Wi-Fi logo will come up announcing the board is ready for use. Once the ES-Wi-Fi module is up and ready for use, the first thing that is needed is to put it into command mode so we can interact with it through the console. We do this by pressing $3 signs. Once it is in command mode, we can then use a question mark to see the list of available commands from the AT command set. We can see from the list of available AT commands, there's commands for setting up the UART, commands for pinging systems on a network, commands for sending and receiving TCP, UDP data on a network, commands for setting up the ES-Wi-Fi module for TCP communications as a server or client, information about the firmware on the ES-Wi-Fi module, commands for scanning available access points on the network, commands for joining access points on the network, finding access points. In order to use the ES-Wi-Fi module on a wireless network, we need to know what networks are in the vicinity of the ES-Wi-Fi module. This can be accomplished by using the AT command set function for searching for wireless networks. To do this, we first put the ES-Wi-Fi module into command mode so that we can interact with it from the console. Then we type an F0 to search for available access points in the vicinity of the ES-Wi-Fi module. From the list presented in the console, we can see that one wireless access point was located called My Wi-Fi Access Point. We can then type F question mark to see how the Find for Network is configured in the AT command set. From typing F question mark, we can see that scan repeats was set to 1 and that scan delay was set to 1000, which in this case is 1 second. Next we can type F1 equals 5, which will tell the AT command set find to find for 5 times. So this will go out and look for 5 separate times to see what access points may be available in the vicinity. This is useful if you're debugging and you want to see if access points are showing up or not showing up in your area, or to get a full list of access points over a period of time. Joining an access point. In order to use the Wi-Fi on the network, we need to join to that network. In order to join the network, we need to know information about the network we're going to join. From using the AT command F0 earlier for scanning for available access points, we found an access point called My Wi-Fi Access Point. From this, we have information available on that access point. The SSID for the access point is My Wi-Fi Access Point. And the security password for that access point is My Wi-Fi Password. And the security mode for that access point is WPA2 AES. And we would like to DHCP onto this network. To do this, we first type a C1 equals My Wi-Fi Access Point to set the SSID. Next, we type C2 equal My Wi-Fi Password to set the security password for this access point. Next, we use C3 equals 3 to set the security mode for the access point, which will be WPA AES. Next, we set C4 equals 1 for DHCP on the network. Next, we type C0 to join the network. After typing C0, we notice that we joined the network My Wi-Fi Access Point, and that the access point via DHCP gave us an IP address of 192.168.1.112. At this point, we can type C question mark to see what information is configured in the AT command set for joining a network. From typing C question mark, we can see that the SSID has been set to My Wi-Fi Access Point. The password has been set to My Wi-Fi Password. Security has been set to WPA2 AES. DHCP has been enabled. For IP, we're using IPv4. And then our IP address is 192.168.1.112. And then we have a network mask of 255.255.255.0. And then our gateway address is 192.168.1.1. That our retries for joining a network have been set to 5, and that our connection status is connected. Ping a system on the network. The first step in pinging a system on a network is to set the target address so that the Wi-Fi can ping the system. To do this, we use the AT command T1 to set the target address. The system we would like to ping on the network in this case is 192.168.1.110. So typing T1 equals 192.168.1.110 will set the target address. Next, we'd like to set our pings to repeat for 5 times. We do this by typing T2 equals 5. And then we would like to have a half-second delay between pings, and we do this by typing T3 equals 500, which is 500 milliseconds, which is 1/2 second. Then we type T0 to do our ping. And we can see from typing T0 that we pinged 192.168.1.110, and we have the information on how long the ping took round trip in milliseconds. Then we can type T question mark in the AT command set to see the configuration set up for ping. We can see from typing T question mark that the ping target address is set to 192.168.1.110, that our ping repeats are set to 5, and that our ping delay is set to 500 milliseconds. That's all there is to pinging a system on the network. Using TCP for data movement on the network. The Wi-Fi module's AT command set supports moving data across the network via Transmission Control Protocol. The Wi-Fi module's AT command set supports TCP, UDP, and UDP Lite for moving data across the network. For the tutorial that follows for using TCP to move data across the network, we'll be using a program on a host computer called Socket Test. Socket Test allows easy setup of either a server or a client for TCP communications from a remote computer or a host computer. In the next tutorial, we'll be configuring the Wi-Fi to be a TCP server on the network. The first step in configuring the Wi-Fi module to be a TCP server on the network is to set our protocol. The AT command P1 will set the protocol. In our example here, we're using P1 equals 0, which is for the TCP protocol. Next, we use the AT command P2 to set our port to 5024. Remote clients will contact us over TCP using port 5024. We can check our TCP communication setup in the AT command set using the AT command P question mark. Here we can see after using the AT command P question mark that our transport protocol is set to TCP, that the client IP address is 0 since no clients are attached to us, that our local port is configured as 5024. There is also the ability to set up a remote host IP and remote host port. And you'll notice that TCP server is not enabled and UDP server is not enabled. The next step is to activate the Wi-Fi as a TCP server on the network. We do this with the AT command P5 equals 1. After entering P5 equals 1, the Wi-Fi will enter a mode where it is waiting for a connection from a remote client. While in this mode, the Wi-Fi is still available for other operations. Once a remote client contacts the Wi-Fi over port 5024, a message will be generated on the console announcing that a connection has been made over TCP from a remote client. Now that the Wi-Fi has been set up as a TCP server and is waiting for a client to connect, we can use socket test that was mentioned earlier to set up a client on a Windows machine to connect to the Wi-Fi. In the socket test program, we want to put the IP address in of the Wi-Fi, which is 192.168.1.112 that was given to us during DHCP. Then we put the port of 5024, and then we hit connect. You will notice in the Wi-Fi module that a connection has been accepted from a client at address 192.168.1.110. Now using our AT command P question mark, we can check the status of our TCP connection. As we know, we're set up as a server. As we can see from P question mark that our transport protocol is TCP, and we can now see that we have a client attached to us that is at address 192.168.1.110, and that client is using local port 5024. We can see that TCP server is enabled. Now that we have a client attached to us, we can use the AT commands to test data communications between the server and the client. We can do this using our S-series AT commands. First thing we need to do is set our packet size. In this example, our packet size is going to be 55. So we use the AT command S1 equals 55. And next we'll set a timeout. And we'll set that to 10,000, which will be 10 seconds. And the AT command S2 equals 10,000, we'll set that. Next, we can do an S question mark from our AT command set to check to see what our configuration is set up for transmitting data over TCP. We can see that we have our packet size set to 55, and we have our timeout set to 10 seconds. Now to send our data, we use the command S0 followed by the message we want to send. In this case, we're sending the message testing TCP transmit communications to remote server. In socket test, we can see that it received our message testing TCP communications to remote server. Socket test is a client to the Wi-Fi, and hence the Wi-Fi is remote to socket test. Now we want to test the capability of receiving data from a remote client. To do this, we set our packet size. We use the AT command R1 equals 55 for receive packet size. And then we can use the AT command R2 to set our timeout for packet reception. In this case, R2 equals 10,000 for our 10-second timeout. Next, we enter R0 to receive data from the remote client. Then using socket test, we send a message to the remote server, the Wi-Fi module. In this case, our message will be testing TCP receive communications from a remote client. Switching back to the console for Wi-Fi, we can see that the Wi-Fi has received the message sent to it from the Windows client using socket test. The next tutorial will demonstrate how to configure the Wi-Fi to be a client on a TCP network to a remote server. The first thing we need to do is set our TCP communication protocol. We use P1 equals 0 for TCP. Next, we use P3 to set the remote server address. Then we use P4 equal to 5025 for a port on the remote server. And then we use P6 equals 1 to connect to the remote server. After entering P6 equals 1, the Wi-Fi will go into a connection mode waiting for a remote server to accept the connection. Once the connection has been accepted, the Wi-Fi will return OK. Communications with the remote server can then begin. Using socket test once again, now configured as a server running on the host, the Wi-Fi can communicate to socket test. Socket test in this example has been configured to listen on port 5025, which is the port that we told the Wi-Fi would be the remote server. You can see that socket test has accepted connection from a remote client, and that remote client is ES-Wi-Fi, which is sitting at address 192.168.1.112. Now using our P question mark, we can check our client configuration for TCP communications. We can see that our protocol is set to TCP, and that our remote host port is set to 5025, and that our remote host IP is set to 192.168.1.110, and that TCP and UDP servers are not enabled since we are configured as a client. And now that we have connected to a remote server, the next thing we need to do is send data to the remote server. Again, using our S commands for sending, we'll set S1 equal to 55 for our packet size. We'll set S2 equal to 5000 for our timeout. And we can see from typing S question mark that our packet size was set to 55 and our timeout was set to 5000, which is 5 seconds. Now, typing S0, which in this case is testing TCP transmit communications to a remote server. We can see that 55 bytes have been sent. Now switching to socket test, we can see that our message testing TCP transmit communication to our server has been received. Now we want to receive data from the host. To do this, we use our AT commands for receiving. We set R1 equal 55, which is our packet size. We set R2 equals 5000, which is our timeout. And then typing R question mark, we can see that our TCP packet size is set to 55. Our TCP timeout is set to 5000. Now typing R0 on the console, we can receive data that was sent to us from the host. Switching back to socket test and entering our message to send, in this case testing TCP receive communications from remote server, and sending this message, we see on the ES-Wi-Fi module that R0 has returned the expected data. As shown in the previous tutorial demonstration, the ES-Wi-Fi module makes embedding Wi-Fi as easy as 1, 2, 3. Thank you for your time.